All right, so a question. How do we test basically two things at once against some diagonal? We want to know if we've got this center of gravity location at some point and some loaded airplane weight at some point. Are we inside of this shape down here? Now, I guess we can also test are we in this shape, but let's keep it simple to start with. So, what we have are 2 points that are pretty clear. This is a center of gravity 41 inches aft of datum, I guess. I don't know what that means, but I don't need to. 41 and 2550. And then down here we've got 35 and 1950. So let's start there. Let's call this point 1 is going to be 35 and 1950. 35, 1950. And P2 is 41 and 2550. Right, so our X, Y positions are those numbers. Now we need to get this slope. So let's do P2 minus P1. And our difference is that this first number is 6 bigger, the second number is 600 bigger, and at that point it's pretty easy to see that 600 divided by 6 is our rise over run. We're going up 600 for every 6 we go this way. Our slope is a nice, easy 100. All right, so m equals 100, positive 100. We want to get the line. Right, so our formula is y equals mx plus b. We know m, and this should be times, and we can figure out b because we can plug in one of these 2 points. Right, so if we say 1950 equals 100 times 35 plus b, I'm going to get an error because that's not proper syntax. But I can then say 1950 minus 100 times 35 equals b. And let's just do that. So b is negative 1550. B equals negative 1550. Comment that out. We've got a value for m. We've got a value for b. Now, we've got some point that we're going to plug in. Let's make up a couple points. So, E3 is, let's say, 37 and 2000. E4 is 37 and let's call this 2200. And we can make up some other ones, but let's just make up 2 simple ones to start with. So P3 should be okay, P4 should be something false. So this is center of gravity limits, so let's call the COG limits is a function of center of gravity location. Let's call that loc for location. And then our loaded airplane weight in pounds. We'll call that weight. All right, so we've got a function and it's going to return either true or false. So let's just make the last line false so that it does that by default. This is basically us setting up the function so that if things go wrong, it tells us not to launch the plane. All right. We want to plug in a location and a weight, and the location is going to be something like 37 and our weight is going to be something like 2000. All right, so what we want to know is the point above here, right? Is it above this line? So we can say let's call it our max weight. this is going to be negative 1550 plus 100 times the location of the center of gravity. Let's just verify that. So if our location is 37, our max weight is 2150. So then we want to say 2200 is greater than that. So we will say return weight greater than, I guess less than, rather, max weight. And we don't need this, right? This is just testing this inequality. If weight is less than, it will return false. If it's greater than, it will return true. The way I was kind of initially thinking of setting this up is to say, basically, if this is the case, then return true. Otherwise, return false. Whatever, I'll do it explicitly like this. I'll write it down this way. The other way. And actually, I guess we could make this even more sparse, but that's a different question. Let's start by making sure that this works the way I'm expecting. So, if I plug in for COG limits, can I just plug in P3 directly? I haven't named it. Let's try that. Okay, never mind. So if I go COG limits with, actually, you know what, maybe I can do alright. I was hoping that would work nicely, but whatever. So we plug in 37 and 2000, we get true. We plug in 2200, we get false. All right. So let me explain what's happening there, and then let me go off on a slight digression on style. So this is the line. So we figured this out by taking our initial points, using that to figure out what the slope of the line is. Right? So what is the slope of this line? And then we just need to figure out how far up that line should be so we get our y-intercept. So now we've got the basic thing, right? We've got the basic line, and we can say whatever y value we get by plugging in our actual details, in this case our weight, we want to compare that to the y value we get from figuring out the height of this line at this location. So we say, okay, we've got a location of, say, 47. We're going to be going out way above this, so we're going to make this a little bit more sophisticated in just a second. But we've got some hypothetical line all along there, and we're just saying, for whatever our x value is, what is the height of that? And if the height that we plug into our function is greater than the height of this line, we're above our maximum weight and we want to return false. So here we're saying if the weight is less than the max weight, return true, otherwise return false. Here we are just returning the evaluation of this inequality. We are returning, is the weight less than the max weight? So if we say 5 less than 10, we get true. If we say 15 less than 10, we get false. This is just a more concise way to write the code. It does exactly the same thing as this. Do whatever works for you. This means that I can fit more stuff on my screen. There's fewer opportunities to have a typo. Really, I'm going to make the same mistake in either case, which is to accidentally make this a greater than instead of a less than. But the way to avoid that is to just do like we did here. So in this case, well, in this case, we've got it returning true if we are under the line and false otherwise. So just be careful, you know, if you want it to return true if we're above this, then we flip that sign. All right, now, while we are here and it's only been 10 minutes, let's think about adding in this also max capacity of 2550. So, we can take this and we can say, or, let's rename this. Let's call this overweight. So we are overweight if our weight is above the max weight, or if our weight is greater than 2550. Not or, this pipe symbol. So if we do overweight for 35, 1950, and let's make this 1940, we're going to shed off 10 pounds. We are not overweight at this point. At 1950, that's when we hit the line. 1951, we are now overweight. Okay. Our function, we might want to be careful, right? If you're selling this to Airbus, you definitely want to double check your numbers here. But for our purposes, this is fine. This is good enough. We are overweight at that point. Are we overweight if we go to 41? We are not overweight. To be overweight, we need to get as high as 2551. That is when we are overweight, when we are above this corner. Now let's try at 2500. At 41, we are not overweight. Let's see how far down the line do we need to be. Looks like somewhere between 40 and 41. So at 40, we would be overweight. Right? We'd be just above the line over here. It's tough to see my mouse, but somewhere over here versus somewhere beneath the line. Cool. What if we are overweight at 45? It's going to be really hard to be overweight, but if we're at 2,600 pounds, we are under the line, or COG limits for 45 and 2,600 indicates that we are not in those limits. Here we've got a less than instead of a greater than. But because we've got the second condition, we're asking, is this true or is this true? Right? If both of those things are, if one of those things is true, then we are overweight as far as this function is concerned. That is one way to sort of build these conditions together. We could also have an and, which would be an ampersand, right? So if we wanted to say, are we, let's just call the function okay. Are we okay weight if our weight is less than the maximum weight based on this calculation? That's good. And our weight is less than 2550, that's good. And let's make sure our location is less than 47. Location is less than 47. And our location is greater than 35. If all of these things are fine, then we are okay. And I'm sure you can see at this point that it's straightforward to make these extra refinements to get this narrower category also. All right, so we've got for 45 and 2600, we are way up here. We're definitely out of weight. Let's go for, let's say 38, 1600. Okay, weight. Double check we got that. False. Our weight is less than the max. Our weight is less than 2550. Our location is 48. Too big. Let's make it 38. There we go. Okay, good. Cool. So I thought it wasn't working the way it was, but I was just missing my own typo. So this is a different way to do it. Again, you could be explicit and lay out your if statement like this, but once you've figured out the basic line, there you're asking, are you above the line or below the line? We can also combine that with other conditions like, is this variable less than this? Is that other variable more than this? These ones are sort of easier to chain together, these last three. because we're just looking at one number compared to some other specific number. The line there, we had to do a little bit of algebra to figure that out, but once we figured that out, then we just ask, are we above or below the line, right? So given some x variable, where should the line be? Where should we be? What is that maximum weight? And then is our weight as given, on either side? Cool. I hope that helps. If that doesn't make sense, let me know, and I'll try and refine that, or we can talk through it in class. I will talk to you in the future.